Hey, welcome back. I'm Corey, and we're about to get started on day 3 of Advent of Code in Rust. If you missed the previous days, check out the playlist in the top right-hand corner for all my solutions. Let's dive right in. Okay, let's get started on day 3. Day 3 is Rucksack Reorganization. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, so a few items now need to be arranged. Each rucksack has 2 large components. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, an A refers to a that is, lowercase and uppercase A refer to different types of items. The list of items for each rucksack is given as characters, all of a single line. For a given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. Okay, so we have these 6 rucksacks. The first one contains all these items. The first half of the characters are in the first compartment, and the second half are in the second compartment. The only item type that appears in both compartments is lowercase p. So we are going to find the item that they each share. To help prioritize item rearrangement, each item type can be converted to a priority. And then I think these... I'm not sure if these are the ASCII values or not. I don't think so. In the above example, the priority type for the item that appears in both compartments is, so you get all those numbers and you sum them up. Find the item type that appears in both compartments in each rucksack. What is the sum of the priorities of those item types? Okay, so basically we're trying to get to 157 for the example. Okay, let's go ahead and get started. So we have our directory where we've been working from, so let's make a new cargo crate. And today we're actually going to do a library, I think. And we're going to save it in 3, and what do we want to call this? Rucksack Reorganization. Rucksack Reorganization. Name it. This is going to be without the 3, same as always. Reorganization. There we go. And then we need to add it to our workspace. 03 Rucksack Reorganization. Perfect. Okay. CD to 03. Oops. Cargo run. Oh, there is no binary because I said we were going to make a library this time. And we did. Okay, so let's open up our library. And we have some functions, and awesome, it even gave us a test. So that's what we were looking for. So in here, we can run cargo test instead. And that's going to run this test. That's going to add our 2 plus 2 and assert equals that we get 4. If we change this test, it works to do something that panics instead. It broke. And then we run the tests again. You'll see that it'll fail because it panicked and it broke. Or we could also, let's do an assert equals. If we try to assert that 1 equals 2, and we run the test, we'll see that it panicked at assertion failed. Left does not equal right, and it has the 1 does not equal 2. So we're going to use a library, and we're going to use the tests to run it. So let's make a test called example input part 1. And we're going to do what we've done for all of these. So we're going to do let the example input equals include string example.input. We haven't made that file yet, but we will. Let's go ahead and do that now. New file, example input. Let's grab that from the site. Paste it in. Okay, so there's our example input. can't read example input. Example input. That's spelled right. Okay. I think it's just not realizing that I put the file there. Yeah. Okay. Let the answer here equals part 1 on example input. So part 1 is going to be a function that we haven't written yet, and we're going to assert that the answer is 157? 157. Okay, so this part 1 function doesn't exist, but we can make one. So we're going to make a public function called part1. It's going to take some input, which is going to be some string, and it's going to give us a U64 like we've been doing for all of our numbers. And let's just do it for the moment to let it compile, and we can run our test. We'll do it right here from the button this time, and we'll see that it failed on not yet implemented. There we go, because of our to do, which makes sense. So let's get started implementing this. Okay, so we have our input, which is going to be each of these lines. So each line is supposed to be a rucksack. So let's make a struct for rucksack. Oops, struct for rucksack. And it has some items in it. Oh, I guess it has a... let's just say that there's items in it. Which is a vec of characters. I think we're just going to use characters. I don't think we're going to use another struct or anything underneath. Because each of these are just a character, and that's pretty fine. And I think that's all we're going to do for that right now. Let's impl rucksack. We're going to implement a parse method like we've been doing. Parse is going to take an input, and it's going to create a self. And this one is gonna just, let's do let items equals input dot characters dot collect. Characters is gonna be an iterator. We're gonna collect it to a vec, and then just do self of items. We don't have to specify the type of items here, because since we put it in the struct, it's gonna be able to figure out that we want a vec, and that's what we're gonna collect over. So that's kind of nice. So then we can do let the sacks equal input dot lines dot map rucksack parse dot collect. This time we do need to tell it what we want, and it's a vec. We're just gonna say a vec of underscore, which is gonna basically be like asking the compiler to figure it out. And then let's just debug the sacks that we get out. We're gonna have to add our derive up here. The derive debug here is gonna let us pretty print this struct basically, so we can run this now. And we should get some nice debug. There we go. So there is our sacks, and then they each have the items array, which is all on the different lines there. Okay, so now I think what we want to do is write a method maybe for the first compartment and the second compartment or something, so that we can like split it up. So let's do like first compartments. Maybe we just do a method called compartments. So we take in a reference to ourselves and we return, I'm thinking maybe a tuple of two things. So we do the compartment, then the other compartment. So each one is going to be like a character array and or a reference to I actually don't think the syntax is right at all. The definition, what is it telling me? Oh, okay, that's not, it doesn't hate me for that. Okay, so what I want to do though is let first equals self dot items 0 dot dot. So then like I need the length self dot items dot length. to that, and then let's second equals self dot items from length plus 1. Can I just do it to the end? And then I do first, second. The size of this can't be known at compile time. That's pretty reasonable. So what do I want to do? I guess I'm just gonna return some 2vex here. That seems reasonable enough. Iter dot collect. So what's the error there? Cargo test. The value of type car can't be built from iterator. Oh, of references. Okay, that's fine. I'm surprised those aren't copy though. So we're gonna call clone on each of the things so I don't have a reference. Okay, what is this? Oh, I can just call 2vex. That's nice. I like that. Okay. So now we can get our compartments out. And I guess what we want to do now is see which ones, like we want to do the comparison. So we want to say which one they both share, right? The only item that appears in both is P. Okay. So, I guess I want to do a function that says matching character. Well, not the one that's matching from each set. Let's do that. Okay, so that you take a reference to self, and let first and second equal self.compartments. And then for C in first, for that one in first, if second dot include contains, if it contains C, then we return C. Then we return sum of C because I'm going to need a option. So we're returning an option. And the reason we're returning an option is because I'm going to need to return none in the base case here. So I need to make sure I needed something to return when I don't find a match. And the easiest way is the none of option. Okay, so now we have matching character. And let's see if we are just getting the matching characters correctly. So we have our sacks. And then let's do let matching equal sacks dot, and let's just get rid of this debug. We're going to iterate over them, and then we're going to map, and on our sack we're going to do sack dot matching character, and let's collect that to a vec, and we will debug out matching. And cargo test. And let's see here. Ooh, index, range index 15 out of range for slice of length 25. Okay. Oh, yeah. Of course, that's what that's gonna say because, oh, cool. We'll look at that in just a second. I like that. Except I don't want length. I want let half equal length divided by 2. That's not even very helpful. Let's just do this division by 2 here. But then the fact that I had to put those in parentheses was less fun to me, so let's do let the half. I don't need a variable for the full thing. divided by 2. There we go. So then this just becomes to the half and half plus 1. There we go. This is better called the like midpoint or something. There we go. And now, okay, there we go. Cool. PLPVTS. PLPVTS. Awesome. Okay, so now we just have to do the numbers thing. So let's do ASCII table. That was a ASCII chart. Any of those will be fine. Because that's not quite right, but it's probably just a translation of it or something. Oh no. Okay, so the ASCII table, we start at, oh yeah, that's the hex. Okay, yeah. So 65, but it's capitals and then lowercase. Okay, so it's not exactly like this, but that's okay. We can figure something out. The easy way is like we could just do a map or a match or something for all of the characters. That doesn't sound super fun, but like it's definitely possible. Let's see what methods we just have on our character here. So matching character. Oh yeah, actually forgot about this. So Clippy is telling me that we can just replace this with a iterator method. It wants us to replace it with a find. So we're gonna look through, yeah, so if we're gonna iterate through all the things in first and find the one that is contained in second. So that's exactly what our for loops were doing before, but now we just have it in one iterator or one line with our iterators, which is really nifty. So now we can get back to actually doing the converting between the things. So let's just what do we want to do here? Let's just do first, let's just make a variable. I'm just gonna take the first character so that I have an option, or let's actually unwrap it too, because all I really want to know is I just want to play with what we can call on character. So we can do ignore equal ASCII case. I think I can do is ASCII alphabetic. That feels like what I want. Can I get you to like, what's your documentation? Uppercase, so those are all 0 is not, percent is not, space is not. Okay, cool. That seems like exactly what I want. So is ASCII alphabetic will tell me if it's ASCII alphabetic. Okay, and then I think I should have also is uppercase, is ASCII uppercase, perfect, or is ASCII lowercase. Okay. So then I think, can I do first.ASCII, is there like an ASCII code or something? Two ASCII, lowercase, make uppercase. Okay. Can I just do first as a you like 64 or something? Like, can I just convert you? Can I just make you a number? Be as U32. Oh, is it just mad because I don't have that at the end? Okay, cool. So I think, let's just figure this out though. Debug first as a U32. Well, change the word debug. Cargo test. It's gonna debug out the where is it? There we go. First as a U32 is 112, and the first one here is the lowercase p, and lowercase p on our ASCII table is 112. Awesome. Okay, so there's the conversion. We just got to tell the characters to be numbers. And we can do the is ASCII. We can, okay. So I think we should be able to do this. So we want to write now a function that is character to score. So we aren't gonna, so we decided not to make a struct for the thing underneath and just to keep it as a character, but It would have been a little nicer now if we hadn't, because we could define the method on it, but instead, we'll just do it as a function, a freestanding function. That's pretty fine. Okay, so if C is ASCII alphabetic, then we're just gonna panic here. We can't handle things that aren't ASCII alphabetic. Because ASCII alphabetic is going to be our lowercase and our uppercase letters, and that's all that we know how to deal with. So now we're going to say if C dot is ASCII, let's do uppercase. Okay, so the uppercase ones, actually, so okay, so what uppercase is going to be 27 through 52. Okay, so we're gonna, if it's uppercase, let's let num equal car as a U32, or actually let's do a U64, I think, because that's what we've been making everything. And actually that doesn't, we can do this outside. And if it's uppercase, we're gonna do let position in the alphabet basically is gonna be from A, so 65, or num minus 65, so that A becomes 0 and everything else is offset by that. And then if it's uppercase, we're gonna do position plus 26. Else, if it's lowercase, we're gonna let position equals num minus, we did 65, so A is 97. And then we just are going to return position because the lowercase numbers are just done like that. This character is actually just C because that's what our variable is. This is just going to tell me not to make the variable. That's fine. Okay, and now we have this character to score method, but I'm not like 100% confident in it. So let's write some quick tests, especially because we have the ability to do that here. So we're gonna do the test test attribute macro, and we're gonna do character scores. And we're just gonna write a few assert equals here. So we're gonna assert equals that the character to score for the character A, lowercase a, is gonna be 1. Is that right? Lowercase, yep, 1 through 26. So then Z is gonna be 26. Need our semicolon there. And then so capital A is gonna be 27. And then capital Z is going to be 52. 52. Okay, let's run that test right there. And let's see if it looks like we failed. Let's see what we failed on. Assertion failed left. Okay, so line 72. Line 72 is our A. Our A is off by 1. Which makes sense because I think what we want to do is in the lowercase case, we want to add 1 to that to make, instead of being 0'd indexed, to be 1 indexed basically. So now let's try that again. And then that's actually the 74 now. Okay, so now uppercases are also, okay, so I actually needed to add 1 to both of these. Which makes sense, because if I 1 index 1, I need to 1 index both of them. There we go, okay. That is now passing, so the scoring looks right, and we have a way to get the matching ones. And okay, cool. I think we are ready to plug it all together. So let's do matching let scores. Let's just make another one. This is going to be a vec of U64s. Actually, I probably won't make the vec of U64s. Okay, yep. We're just going to go matching dot iterator dot map. So here, this is going to be an option of a character. So we're going to do c.unwrap. So we're going to say there's always, and actually instead of unwrapping this time, we're going to use an expect and write a message. There should always be a character in both compartments. And then, okay, there we go. So we can, now we just have our character, and we want to pass that whole thing to char to score. Okay, that's the map. I'm not sure why that's not breaking any better for me, but that's okay. And then once we map it, we just want to sum them. Because now we have all our scores, and I think we actually just return that. Cool, there we go. I really want this to break onto some lines here. I feel like that's gonna read better. Okay. Let C equal C dot expect. Take this whole expect string, put it here, then do that. This just becomes C, but we need to wrap this like that now. Oh, so close. Ah, there we go. Okay, now broken onto two lines. That looks a little bit better. And does this actually pass this test now? Awesome. So it works for our example input. And let's write a test for our like our my input that we're gonna grab in just a second. So this is gonna be my input. And actually we could have just called this input and then we wouldn't have had to rename it. Well, let's make that my input, new file, my input. Let's go grab the input. Okay. Go back to our library and run it. It's going to fail because we still have 157 from the example plugged in. And the answer it wants to give us is... Ooh, okay, so we actually got an error. We found that there should always be a character in both compartments. So there was one place where we didn't find a matching. But I wonder if we actually just need to... I wonder if we just have an empty line or something that we need to trip. So let's try that first. Trim. Nope. Still failing. Okay. Let's at least get some more information out of this here. Let's actually just debug our... Oh wait, no, we know that C is just gonna be a none. So that doesn't help us a ton. What I really, I guess, want to know is... Do I just want to debug matching? I guess let's try that. I don't think that'll help me get the answer, but what I think that will do is let me see if it's just at the beginning or the end, which I think is going to be nifty. Okay, so most of these have a matching. Some of them do not, though. Okay. Oops. Okay, so let's like figure out which lines are giving us problems. There we go. Okay. So from our sacks, let first issue is going to be from the sacks. We're going to iterate over the things again, and we're going to find one where s dot matching dot is none, and then debug our first issue. Oh, okay. Probably could have not debugged the whole thing because that's just going to be huge. That. Okay, this one is the first issue. Okay. So FB, is that one I'm just gonna be able to find easily? FB. Oh, is it this first one that ends in PV? Yeah, okay. That's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18, so 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. So D should be the answer to this one. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I think it's probably just a off by one-ish issue in my splitting by compartments code. Ah, this is not inclusive, but this is, so I don't need the +1. Now, if I run this for my input, I think I will hopefully get they equal different things. There we go. So 8085 should be 8085. There we go. Awesome. Okay, so let's go back to the test here and plug that in. So this is actually 8085. And now we can do cargo test. And we pass all of our tests because that is the correct answer. And nothing changed when we ran it again. Awesome. So let's commit that. Close that one. Day 3, part 1. Okay, and let's read part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying and at most 2 of the elves will be carrying any other item type. All 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. Not really sure about that last sentence, but that's okay. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, and the second group's are the next 3 lines. In the first group, the only item that appears in all 3 rucksacks is lowercase r. This must be their badge. In the second group, their badge type must be Z. Okay. Priorities for these items must still be found to organize the sticker attachments. Here they are. So those are the same, and we just find. Okay, so we're gonna find the group's special letter, the one that's in each thing, and then we're going to sum their scores again. Okay. So the first thing that we need to do is we need a way to group our rucksacks into groups of 3. And in Rust, I know that we definitely could implement this ourselves, but I know of Iter is a nice crate that gives us lots of tools that we can use on iter. So it gives us all of these functions that we can chain off of iterators. And I think one of them is going to be basically exactly what we want. I just have to remember which one it is. Okay, so we have all any chain cloned concat const tuples maps example for iterators of that to that. That's not quite what we want. I want one that's like interleaving to max merge, multi-peak, partition, that's close, peak and I want to I thought there was one of these that I was just gonna be able to basically use. Partition, put back, repeating. Okay, none of those are exactly what I was hoping for. I want to take the iterator and transform it so that I can Rust iterator groups of 3. Is it possible to split a vector into groups of 10 with iterators? Yeah. Chunks. Oh, and it's even on oh, I can call chunks on T directly. Oh, what does chunks do? You call it on the slice and it chunks it into those numbers. That's exactly what I'm looking for. Cool. Slice.chunks. Okay. That should make this pretty easy. So let's see. Let's define our part 2. Well, where is our part 1 method? Part 1. There we go. Okay. Public function part 2 takes an input string and returns a U64 again. Okay, so we want to get our rucksacks again. And then we're going to do let groups, which is a vec of something, equal sacks dot chunks of 3 dot collect. Yeah, and then we can debug out our groups. And then the last thing to do here is actually make a test that will call this. Actually, let's just copy this one from up here. We will put it at the bottom though. Example input part 2. And then part 2. And the part 2 example answer is 70. Okay, so we have this. This will fail if we run it because, well, one, it's not going to compile, which is an issue. We don't have it returning the right type, so let's add that to a magic to do like we've been doing. That'll let it compile. It'll panic, but it'll compile. But it's actually going to panic before that when it runs because we did hit the to do not implemented. But we will see that our grouping worked. We have rucksacks grouped in groups of 3. 1, 2, 3. Perfect. Okay, so we have our groups now, and in each group, we want to find the item that exists in all of them. So let's do let matching again. They call them badges, so let's call them badges. Equal groups dot groups dot map iter dot map, and then we have our array of 3 things. So then this is a group. Yep. So then our group is going to be an array of the rucksacks. So let's do let first, like I know there's 3 things in the group, but can I just do let sets equal, getting a little bit ahead of my talking, but that's okay. So from the group, I want to map over. I can't map over it, that's okay. I can iter over it, and then I can map over it. And then this is going to be a rucksack. This is going to be an actual sack. Hehe, sack. Okay, so set items dot to like I want to make it a hash. I want to use a hash set here. So let's hash set import hash set dot from iter. Wait, what do I have here? From s dot items from iter items dot into iterator hash set. So we map to the hash set. So I want this to be a vec of hash sets. There we go. Hash set. What don't you like about this here? Oh, a hash set of what? Hash set of characters. Okay. So then let matching equals or like let like I want to reduce this, like sets dot reduce, or like fold iter into iter dot fold the initial value of the fold. The initial value is the value the accumulator will have on the first call. Yeah. Well, that's annoying because I want it to be like, I guess, is there a reduce instead? Yeah, there we go. Okay. Reduce it. And then it's actually, I don't know how the signature of this works. Reduce takes in a function of two items, right? Because we're reducing them to, okay, yep. So it's like x and y, and it does x and y. It's gonna like do the intersection, x dot intersection with y. Intersection. Why doesn't it like that? Intersection dot to set or something. Cargo test. The trait from is not implemented for hash set. Yeah, I will. Okay. The into didn't help. Um, intersection. Yeah, like I get that it found an intersection. What do you return? Like I know you return that, but like how do you expect anyone to use you? Ah, it's an iterator. Got it. Let me just collect it again. Now what are you mad at? The value of type can't be built from. There we go. Okay. Okay, so I'm just changing this to, instead of how we construct the hash set, instead of doing the from, we'll just iterate and collect it. Oh cool, this one, we don't need that because we don't need that. We don't need that. We can just do all of this in one go. This though, now it needs a type because now it doesn't know what we're talking about anywhere. So we tell it one type and it should be good to go. We get the badges, which are like a well, now they're not a vec yet, but they would be their item here is an option of a hash set of a car. Is it an option? Oh, clone collect. I'm actually not sure where the option. Oh, reduce probably returns an option if the thing's empty. Yep. Okay. But let's just unwrap that. We don't think we're gonna have an empty one. So this, its item is now just a hash set of characters. Awesome. Except what I really think is I think it's just gonna be a single character. So dot to vec. Can I just like get the first thing out of it? How do I get something out of it? Dot. Yeah, I can't just call to vec on you. I cannot. Okay, that's fine. The badges, so then like this is let in all, where in all is then the hash set. So then let in all as a vec of characters equal in all dot into iter dot collect, and then we can do in all at 0, because here we're assuming there is going to be only one thing. I could even just add in a debug assert equals, so that in debug mode we assert that the length of this is 1. So now we just make sure that the assumption we're having is going to hold. We're going to say we want to make sure that there's only ever one thing here that we're about to pull off. And these are our badges. And we can probably just iter.sum them. Not quite that though. We can map our character to score. And then we can sum. Badges, isn't this in all? Yeah, so this thing, dot collect. Oh, I see, badges. This is on groups, not badges. Except actually, I don't even really need to debug this. Let's just like use that. It's the right thing there. Let's not make that. Keep it an iterator so that we can just do this. There we go. Awesome. Now let's run it for our example here. And awesome, cool. Works for the example input. So let's copy that one. And my input, my input, we're going to say it's going to be 70, but it's not going to be. Our part 2 answer, 2515. 2515, and there we go. Awesome. We completed day 3 of Advent of Code in Rust. I hope you enjoyed that video, and I hope you're following along with me for all the puzzles. Day 4 will be coming at you soon. If you like this, please sure to give me a like and subscribe to the channel to know when the rest of the series is coming out. Thanks, and I'll see you tomorrow. Bye.